but this is not the last one. So, the investigation of wave energy harvesting in Malta. Carried out by National Airport of Malta, it was seen that the Iceland are greatly affected by different winds through all the seasons, by winds blowing at speed ranging from 1.8 kilometers to 39 kilometers, equivalent to from 1 to 21 knots. So the International Energy Agency estimated that sea waves energy could in fact produce 10% of the global energy demand, and the energy sector Malta faces two issues, this being the amount of CO2 emitted daily and reaching the from 22 to 2030 and 2050 targets as the European Commission required. Analysis the potential wave energy around the coast of Malta in view of national energy targets. A time domain model was developed to analyze the wind and wave data over a specific amount of time. The energy potential in the waves is calculated with different potential offshore wave energy converters was used. This study would help determine if sea waves harvesting would be feasible and successful while contributing to the energy sectors. And attenuator and oscillating wave surge converters and point absorb wave energy converters are considered to extract the largest amount of energy possible from the Maltese archipelago. The main aim is to develop an analytic frame from sea waves energy harvesting Maltese island. So the main difficulties of designing new technologies is regular wave amplitudes, phase and direction, creating difficult to obtain the maximum efficiency. The load, the structure can be handled in extreme weather condition, and the slow motion waves with a low frequency, coupled a generator which would require high frequency. The wave energy converters was used for analyzing this research paper is divided in two categories, location and time, and making in six categorizations. So we prepared the capacity factor of them, and we will introduce in our calculations. Useful methodology using for calculation MATLAB program, selection of site and analyzing with Excel and MATLAB domains programs. So, which can produce the greatest amount of electricity was the main questions when making researchers. These devices were considered and chosen for the study. Science each has undergone a full-scale testing and verification in the ocean. So this information provides the expert provide that can be made for the future experiments. So methodical is multiply criteria decision-making problems where the alternatives are defined, and to make the best options to use both the agreements and the discordance concepts. This method was developed as a wide sums based tool which could be used to solve concrete multiply criteria real world problems. So, including the amount of energy generating during different time periods, the wave energy consumption were affected by the wave activity in Malta. Useful methodologies and devices was comparing here how each other can produce total electric energy in different times, was useful 2 days, then week and month and yearly data. So Wave Dragon have produced a total of electric energy more than 6,000. Then Oyster Wave Power 184, and Aqua could not produce any energy at the date. So energy production during one and another day is changing the data. Still the Oyster Wave Power showing that this curve is not producing electric energy what we expected. And energy of the month of all March, Wave Dragon was the big amount of electric energy produced. So for the year energy production, we can see those data from the Pelamis, the Wave Dragon, and the Aqua, and was made the solution and the final option that Oyster Wave Power would be the optimal choice for the Maltese island. The Pelamis and Wave Dragon are not comparable with the Aqua broken last. So during the study, a factor including the energy produced, the levelized electricity cost, the capacity factor, what we also made with the economical side of operation were determined for each device with consideration of these factors. The optimal device for Malta could be determined. Wave Dragon, the Aqua, requires a minimum wave height of 1 meter and the time period of 5 seconds, which could affect the operation of the device since the average wave height is close to the minimum requirements. And the results discovered that following the Pelamis only produced 252, and the rate of economical 1.12, while the capacity cost are moderate and the capacity factor is one of the biggest comparing to others. Technologies. This device will operate for a total of 8 months. So thank you for your attention.
Thank you very much. Do we have questions? So it seems from results that then wave energy is not a good idea for Malta. Is that correct?
As for this moment.
For this moment.
Maybe we will find technologies.
Next MEDPOWER meeting.
Yes.
Okay. Thank you very much.